Hello, folks. So we are back again with yet another interview question, and we have Dev with us, who is going to attempt this question. Now, this is a very important and a question which is dear to me. The question is, it's deceivingly simple yet again, where we ask for a custom implementation of malloc and free. Now, when I say custom, we are free to use the standard C library implementation of malloc and free within, but this implementation has one more restriction where we also ask a memory to be aligned when we allocate it. So for example, if I'm asking for five bytes of memory and alignment of 4 bytes, so what I mean is I want the chunk of the 5 bytes, but the starting address should be aligned to 4 bytes. The custom malloc takes two arguments here. One is the size, obviously, which the traditional malloc also takes, and the second one is the alignment. Now, this alignment could be any power of 2. So it could be, we can ask for a single byte align, which would be similar to malloc. So if I pass, alignment as 1, it will behave as if the traditional malloc should behave. But again, alignment could be 2, 4, 8, 16, and so on, which could be any power of 2. And what we expect is a pointer to a block of memory with the size of what we have given, but we also need the address to be aligned by the alignment. And similarly, custom free is we want to free that block. So yeah, let's dive right in.
Okay. So I want to ask few questions
Right.
to understand the problem thoroughly. So I'll have some comments here as you answer my questions. So uh, let me understand that I have given the malloc and free APIs internally, right?
Yes, yes.
Okay.
So you are
So
free to use any standard
assuming, okay, I have
library.
malloc and free APIs available. Okay. Uh, okay. So when I call malloc with, okay, so what I am trying to do is, so I typically call malloc with some size, let's say 5,
Mm-hmm.
right? So what it returns is the memory. So what I usually think is it will return the memory aligned to 4 byte. Is that correct?
Will it?
Like I, at the moment, I don't have that information. If
No.
it
So
will, okay.
there is no guarantee that it will
Okay, so it can return to any
any
integer,
addresses. Yeah.
right? Okay. Oh, that is interesting. What I was thinking is that if, let's say, I am asking for 4 byte of memory, it will return 4 byte aligned memory. But okay, that's not a. So
I
it
mean,
returns.
so in small cases, yes. But let's say if I want bigger
Hmm,
chunks, like
hmm,
I want a memory block to be aligned by 64 bytes.
hmm.
So in that case, it may not return. Right?
Okay, so like
You get
in most of the cases,
Yeah, and
it
here,
doesn't.
why does it have to return 4 byte aligned memory is because the architecture sort of guarantees or sort of restricts us to. So you
Hmm,
cannot have an unaligned access of
right,
an odd address, right? So that's why
right.
the maximum alignment it can cater is 4 bytes.
Okay, okay. Okay, and then when I use free, I
Hmm.
have to give the base address pointer or whatever malloc returned to me to be able to free it. Okay.
Right, right.
Now in custom, I am given a size and alignment. So let's say if my size is, let's say, 5 bytes, or let's say
Hmm.
1 byte, and then
Maybe
alignment
can
is,
you just for our viewers, can you take a bigger size number just so it really hits it right in the head?
yeah. But what I'm trying to do
Hmm.
here is that I want to check all the cases what it will
Okay.
return. So I'm
Hmm.
taking first very simple example to
Hmm.
understand. In that case, what happens, right? So if my alignment is 0, that happens to be 2 to the power 0, right? That is a valid input,
Right.
right? So in that case, it can return anything, right?
Yeah, it
Like
can
if
return.
if a byte uh, with this address is returned, I wouldn't mind it, right?
Right.
Because this is a valid output. Okay. Now, if the size is 1 and then the alignment is 2, let's say 2 to the power 1, I will remove this part here. Then what I am assuming is that
It
uh,
has to return an even address.
even address.
Right.
Okay, 2 to the power. Okay, 2 byte alignment. So
Mm-hmm.
even okay. And what I could do is that okay, I use malloc internally
Mm-hmm.
to ask for let's say okay, so it can return any byte, so at least I'll have to ask for 2 bytes.
Right.
Okay, so if I ask for let's say just 1 byte, then malloc will return this value, right?
Mm-hmm.
And now all I have to do is to make it align to
Mm-hmm.
2, right? So what I do is I will, so my memory is from this to this, right? Only 1 byte is there. I
Right.
can't really align it. So I have to ask a bigger size. So this is
Mm-hmm.
a normal size. I have to ask for some bigger size. So let's say call it b size, or that would be let's say 2 byte.
Mm-hmm.
Now if I ask for 2 byte, then that suffices me, because even if it returns 351,
Mm-hmm.
what the bytes I have at my disposal is
Mm-hmm.
0x351 and 352.
Correct.
I can just return 352, right?
Two. Yeah. To your caller,
Caller.
basically. Yeah.
Okay. So that is what we
Hmm.
want here,
And
right?
here, I think I understand it perfectly. But
Mhm.
the line size at line 9 is the size which is going to be passed to your custom malloc,
Right.
right? And the size at b size at line 11
Hmm.
is what you are going to pass to the malloc call, which will call
Right.
from your
Yeah.
custom malloc, right?
So yeah. So all I have to make sure is that okay,
Mm-hmm.
whatever malloc returns to me, I
Mm-hmm.
make sure that okay, when I return back to the caller of the
Caller.
custom
Mm-hmm.
malloc, I need
Mm-hmm.
to have that uh, the pointer aligned to this
Right.
whatever alignment I have given,
Exactly.
right?
Yes. Yes.
Okay. And since malloc gives me any byte alignment, so I have to make sure that okay, I ask for some additional memory so that I can offset to that alignment,
Right.
right?
Right. Right.
And in that case, one uh, problem here is that
Mm-hmm.
I would end up wasting some memory, but
Mm-hmm.
that then I'll have to deal with that, because there is no other
Right.
way for me to
Right.
make it alignment, right? Unless I have some argument to the malloc as well as an alignment being passed, right?
Then
But
it would be, yeah.
right.
Then it's like a wrapper. I think
Okay.
we don't have the argument to the wrapper.
Right. Okay. So here, what I got from these two inputs is that if my size is 1, alignment is 2, then I'll have to at least have a
Mm-hmm.
base of 2, right?
Mm-hmm.
Uh, okay, that is the
Maybe
one.
I want to probe you more, and also, can you
Yeah.
complete the entire flow now? So you have passed 352 as
Right.
the return argument to the
Yes.
caller,
So
right?
what I did was, so internally, I got these arguments as an input. I called malloc with b
Right.
size as 2, so malloc 2,
Mm-hmm.
and let's say it returned me some odd address, right?
Right. Right.
If it returns me even address, that is fine,
It's fine.
great. I
Mm-hmm.
just return back to the user.
Mm-hmm.
If not, then I'll make sure that this byte is aligned. So I have got the 2 bytes. I'll have to return just 1 byte. So what I
Correct.
can do is, and because of I requested 2 bytes, because either one of them will be of the even alignment, right?
Right. Right.
Right. So
That's
since
fine.
they
That's
are
fine.
consecutive,
That's
so
fine.
one of them will be aligned. So whichever is aligned, I'll return that.
Correct.
Right.
Correct. That's fine.
Yeah.
Now, what
So
will happen in free?
yeah, I think that's another thing that I need to
Hmm.
understand, because when I receive 351, when I call malloc like the internal free, I have to return. I have to use this 351,
Correct. Correct.
because I
So,
can't use 352 because
right.
it doesn't know that
Right, right.
address.
So you have to return the pointer which malloc assigned to you.
Right.
You cannot
Right.
assign. You cannot pass any other pointer to free.
Right.
It
Yeah.
has to be that.
Yep. Okay.
So I wanted to
And
probe you and maybe complete this line of thought, because I see if this is solved, then basically it would then be just molding of this
right.
in a bit,
Okay.
which will solve all the cases.
Yeah. Okay. So what I'm doing here is that okay. So one approach that
Mm-hmm.
comes to my mind is that I can have a mapping, right? Let's
Mm-hmm.
say I got this from the malloc, and I'm returning this to the user.
Mm-hmm.
Then I'll have a mapping from 352 to 351. So when user gives me back
Mm-hmm.
352, I should be able to convert it back to 351,
Hmm.
right? Because one interesting thing here is that based on this calculation, I can even go back to the, let's say, original base pointer,
Mm-hmm.
theoretically. But since I'm not given the alignment here as well as the size, so I can't really go back to the pointer. So what I was thinking is that, let's say, user gives me 352,
Mm-hmm.
and then if let's say alignment with it, then whether okay, even in that case I don't
Even
know
in
if,
that case, yeah.
yeah,
Even you
I,
don't know because what malloc
yeah,
returned to you, right?
right, yeah. So I was thinking if it is odd,
Mm-hmm.
then I can think okay if it should be even,
Mm.
but if it is even already, then I don't know okay what
Right,
happens.
right, right.
Yeah. Okay, so that won't work. So what I can think of is I can have a mapping,
Mm-hmm.
some sort of hashing here, where I'll have a this kind of hashing where hash,
Mm-hmm.
uh, you know hash, and then key would be let's say 0x352, and then my value will be 351
Mm-hmm.
0x351, or maybe offset just one or whatever
Yeah,
minus
yeah.
one. Uh, and whenever in free, I will receive this 352 because
Mm-hmm.
that's the value I return to the user.
Correct.
So I'll use this hashing and get back to this 351.
Right.
And then when I call the free API of the inbuilt libraries, I will call with this 351.
Mm-hmm.
So that is
Understood.
what I'm thinking. If is that fine with you?
I think that's one way to do it.
Hmm.
Now, can
Okay.
you maybe? I mean, there are two ways. Maybe we can just
Okay.
start implementing. Let's go with that. Let's go ahead with that.
Okay. You assume. Okay. You want me to go with this flow?
Yeah, yeah, yeah. Why not?
Okay. 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 Fine. And also, some more inputs I wanted to have
Mhm.
here.
Yeah, yeah.
But
Let's
this
do that.
is, yeah. So before going ahead,
Mhm.
let's say size is 1 and then alignment is 4, then I'll have to go with the alignment. Okay,
Mhm.
let's is 4, let's say. Then base, what should be base size so that I can make sure it is aligned. Okay, so if I return max of 2 will work or not, because alignment is 4. Here it was max of 2, right? Just
Right.
1 and 2.
So
Here
I
being
mean,
the
one way
size.
to look at it is alignment.
This,
Whatever number we have in alignment, right?
right.
The
Mhm.
address we get should be multiple of that.
Yeah, yeah. So even in this case, it should be 4. If I get
Mm-hmm.
asked malloc 4 bytes,
Mm-hmm.
at least one of them will be aligned to 4, right?
Mm-hmm.
So I can go to that address and then align it.
Mm-hmm.
And when I say that align it means I'll have to find an alignment bigger than the whatever address I received,
Mm-hmm.
right? Because let's say I got, let's say, 351 in this case as well.
Mm-hmm.
Then what I can do is I cannot go to 350. This is
Correct.
also 350 is, the
Right.
the
Right. Right.
the left side shift is there, right? Like the smaller number which is aligned to 4 is this,
Mm-hmm.
right? But we'll have to go with the bigger one.
Mm-hmm.
Let's say 354. Is this aligned? 352, I guess.
354 in hex,
Uh,
right? So if it is, let's say, if it is decimal, then
yeah,
because you have to.
32.
Hmm.
Yeah, I think, yeah, like let's make it decimal, let's say.
Hmm.
Then this is divisible, right, by 4, I guess. Yeah, it should be either
Hmm.
352 or 354,
4.
one of them. Uh, 32. Yeah, it should be. Yeah.
This 350 won't be, 352 will be.
Yeah, 352 will be. So what I make sure that I'll go bigger than that.
Hmm. Hmm. Hmm.
So okay. If I convert 351, so what I'm thinking is that how I make sure I go to that size. That is what I want, right?
Mm-hmm.
What I know that, okay, next 4 byte, the one byte will be aligned to 4, but then whichever is that, right? I need
Right.
to find that. And for that, what I can do is I will make sure that 3351, the last 2 bits are 0, right? So that then the smaller than 351, which is aligned to 4, right? If
Okay.
I know that value, then I can go and then add +4 maybe,
Hmm.
and that should be
Hmm.
aligned
That's
to.
one way to do it.
Yeah,
Yes.
yeah,
I think I get it.
yeah,
So so you're saying is you'll basically clear all the
yeah, two
required
bits
LS base
Yeah,
from the address which we get from malloc and add 4
yeah.
to it.
Let's say this value was this one, right? Let's say
Mm-hmm.
this translated to some this number.
Mm-hmm.
uh, Hypothetically it's not correct, of course, but so what I do is
Right.
I'll remove these 2 bits,
Mm-hmm.
you know remove as in like reset these 2 bits,
Yeah. Yeah.
and then add 4, let's
Correct.
say, right? So then this is aligned to uh, 4, but it is lesser than 351.
Mm-hmm.
That memories I don't have, so
Mm-hmm.
I'll go and add 4. So I'll land into one of these values, right? which I have. So that should be correct, I guess. Now, next thing is, let's say my size is not 1. Let's say size is 2. And then here, if let's say size is 2, alignment is 2, I have to ask for, let's say, if I got 351, I can't just make up with that. So I'll have to increase the size. Let's say I got size 3. Okay. So let's say 3 can work, I guess, because let's say if I got 351, let's say 0x, the 1 is the address, let's say, I got from the malloc. So I want it to be aligned to 2. So I can go 0x2, right? That can work. But then 2 and 3. Okay, 2 and 3 is there. Yeah, that can work. So what I want is that, one of the simpler ways that, I don't have to think about anything if I
Right.
ask for,
Maybe
let's say,
can you
size
go
plus
for a?
alignment, right?
I think what you are doing is trying to find the best possible
Yeah, yeah, yeah. Best
solution
sweet
for the
case where
specific for
I
those particular alignment and size values. Maybe
right.
think of a bit generic approach where it
Yeah,
works for everything, but
yeah.
we'll waste a bit more bytes basically.
Yeah, yeah, of course. So what I was thinking that, okay, if there is a
Mm-hmm.
sweet point where, considering these two values, I identify b size to be smaller one, so that
Mm-hmm.
I waste less memory.
Right.
But the one you know straightforward would be that if I ask for size
Mm-hmm.
plus alignment,
Mm-hmm.
then I make sure that, okay, whatever is size, and then I add up the alignment, then
Mm-hmm.
that should be sufficient for me,
Mm-hmm.
because somewhere in this alignment I will find my sweet spot, right?
Mm-hmm.
And then from there I can make sure, okay, this is the size I'm returning, right?
Mm-hmm.
So let's say, just to have an example, let's say 5 plus 4, right? So 5 is the size and 4 is the alignment. I ask for 9. Now I know that, okay, these 4 bytes that additionally I have allocated, in one of these bytes, the the memory will be aligned to alignment, right?
You will get an
One of the
address which
byte
is
address
aligned
will,
to
yeah, yeah,
four, at
yeah,
least one address.
yeah. One of the byte address,
Mm-hmm.
these are the additional byte I have added, right?
Right, right, right.
And one of these bytes will have an address which would be
Mm-hmm.
aligned to 4.
Mm-hmm.
So that is my idea, right?
Right.
I think that's uh, way to go forward, I guess, for a
Mm-hmm.
generic solution.
Mm-hmm.
Okay, I think I have all the pieces in place to implement it,
Okay.
right? That is okay. Let me write down the code here.
Sure, sure.
Okay, is it enough to be visible?
Yeah,
Bigger
I
enough
think
to
so.
be
I
visible? Okay.
can. Yeah, I can read it.
Okay. So if my alignment is okay, so what I ask for is, anyway, like I don't have to take that case separately, but if let's say my alignment is 1, I just return malloc and
Mm-hmm.
size, right? Because alignment is 1,
Maybe
that's
can you
what malloc
uh,
does, right?
fix the spelling in 29?
Alignment. Okay. Is that what you meant?
Yeah, yeah, yeah.
Okay. Remove space here. So what I am doing now is that,
Mm-hmm.
if let's say it's not alignment is equal to 1,
Mm-hmm.
then what I do is, I take void pointer and then call malloc. Let's say,
Mm-hmm.
okay, it will return void anyway, so I don't have to do anything. Malloc
Mm-hmm.
and then size plus alignment, right?
Mm-hmm.
And whatever is this address, I make sure that it is converted back to
Mm-hmm.
some integer values. Okay. So what I want is, I reset those number of bits, right?
Right, right, right.
Okay. So what I need to do here is that, let's say I'm given 4, then I should know, okay, I need to flush 2 bits,
Mm-hmm.
2 lsb bits. If let's say 8, I need to flush 3 bits, right?
Mm-hmm.
Now, is there any way for me that you are given such a log 2 function, right, to
Mm-hmm.
calculate the power of the 2 in alignment? Can I assume that, or I can calculate that as well,
Mm-hmm. Okay. I see what you're saying.
right?
You
So
can
let's
assume.
say,
You can assume. Yeah.
yeah, I
That's
think if you want me to implement, of course I can
yeah.
implement.
But it's fine.
uh,
I think
yeah. So
that's
let's
not
see.
the
Yeah,
main track of the problem. So
yeah. It's just like dividing
right.
alignment by
Yeah.
2 multiple times, right?
Yeah. Yeah.
It's very simple. Power is there, whatever power of 2.
Right.
uh, and then
So
what I do
just for our
is
viewers, what Dev is doing here is whatever alignment we give, we will give in terms of like 1, 2, 8, 16, 32, 64. So he
right,
wants from 64, he wants to get to the digit 6, basically.
right, yeah.
And that's what line 33 here does. Yeah, okay.
And then for these many bits, I'll clear those bits. So what I can
Mhm.
do is okay, what I need to
Sorry.
do is first of all, I need, let's say I need to convert
Mm-hmm.
u int 6040
Mm-hmm.
uh, address, let's say call it address, and then I so I'm trying to convert this pointer to this address
So this
uint.
number.
Yeah, yeah, because that's the maximum size the pointer can
Right.
have, right? So
Right.
I want to convert it first to an integer,
Mm-hmm.
and then flush out those bits,
Mm-hmm.
right? So address and is equal to uh, now whatever power of 2 I have,
Mm-hmm.
I need to shift 1 by these many bits. Let's say I have 3 as the power of 2, right? Let's say 8 was given, I calculated
Mm-hmm.
power of 2 was 2 was 3, right? Now what I need to do is to clear out 3 bits. So what I do
Mm-hmm.
is 3 minus 1. So this will
Mm-hmm.
do is what this will do is
Mm-hmm.
have 0 b 1 1 1
Right.
0 0 triple 0, right?
Uh, 1 shifted by 3 will be yes.
Yeah,
And then you do minus 1 of that, right?
yeah, yeah.
Okay.
So what I do is I will do minus 1.
Mm-hmm.
That means it will have, let's say, 0 b
Mm-hmm.
0 1 1 1.
Mm-hmm.
What I'm trying to do is clear these 3 bits,
Mm-hmm. Okay.
and then I'm trying to negate it with, let's
Mm-hmm.
say, whatever value is this,
Mm.
I negate with, so that should be like it will return something like 0x 0b all 1
All ones
to
and
whatever
last three
size
zeros.
and last 3 zeros, right? So that
Right.
way I'll clear out those bits, right?
I see. Yeah. So
Okay,
essentially making a mask of
yeah, yeah.
it. Okay.
So what I was wondering if there is a way, direct way for me to calculate, right? Because this is anyway there, right?
Hmm.
This is anyway there. I don't have to calculate even power. Maybe
Exactly. Exactly.
I'm trying to calculate
So you
power
are
here again. Yeah,
calculating the power and then shifting again,
yeah,
generating the same number.
yeah.
So,
So what I do is instead of power, I
hmm.
just use the alignment.
Right.
Alignment minus one,
Hmm.
and then negate that.
Hmm.
I think the preference is correct. I guess like
Right. Right. I
yeah,
think it's fine.
because it will do first. It will negate,
Yeah.
and then
Or maybe if you are not sure, just add
yeah,
parentheses.
yeah, yeah, fine.
Okay.
And just to make it readable, let's
Hmm.
say this is address, and then this is what I wanted
Hmm. Hmm.
all one. So it will clear out those bits, and then I'll return address plus address is equal to address plus, or let's say address plus alignment,
Hmm.
right?
Right.
And before returning, I kind of have
Hmm.
a hashing here.
Hmm.
So okay, I think there are ways you can implement your hashing.
Hmm.
What I'm doing here is that let me use some sort of inbuilt function.
Okay.
I can of course implement hashing, but let's say this is C, but I'm using C++
Or maybe you
SQL.
can assume that we are given two hash APIs. Just
Okay,
right.
okay,
Feel
okay.
free
Let's
to.
let's say okay, okay. So what I do is I insert.
Mm-hmm.
So what I have to do is to insert key and value address,
Mm-hmm.
and this was my key. The key was address before it. No, this was a value. Okay, okay, this is key,
Mm-hmm.
and then value is this. Sorry, key is this. This must be value. So whatever
Just a second.
returned
Hold on,
from,
hold on.
okay,
What you are saying? What is your key?
let me just give me a moment.
Yeah,
I
yeah, sure.
need to clear out first. So whatever the key is this.
Right, right.
Sorry, value is this because this is what I
All right. So
got
you are
returned.
following the. Can you go back to line? Scroll up. So maybe we'll show our
Yeah. So
viewers.
what
Yeah,
I'm trying to do is this is
line
the 352
24.
is
Hmm.
okay. Let me have this here.
Yeah.
Here, let's say, and
Hmm.
351 was returned, right?
Hmm. Hmm. Hmm.
351 was returned. So this is the address was returned,
Hmm. Hmm. Hmm.
and then this is my value
Right, right,
351, and then key would be whatever after I receive, right? Adding the alignment and all.
right, right.
This is my key,
Exactly.
right?
Okay, okay. Got
So
it.
I add key and value.
Hmm.
Address will be value.
Hmm.
Let me remove it from here. Value is this. Address updated. Added
Hmm.
correctly with alignment. This is key. This is value. So I insert. Let's say hash insert,
Okay.
and then key and value,
Hmm.
and then what I return is this address, right?
Hmm.
Before I return it, I need to convert it back to the void pointer
Hmm.
because that is what I was asked.
Yeah.
Okay, and then I'll have to declare here uint 64 key and value,
All right.
and also address as well, which is declared there. I'll remove it here.
Hmm.
Okay, so these are a bunch of operations that I need to perform.
All right.
Yeah. Now for custom free, I got this pointer.
Hmm.
What I do is just call free with, let's say, hash insert hash find,
Hmm.
or okay, let me have some sort of troubleshooting here as well, like catching the errors.
Okay.
So so u in 64t, and whatever address I have is the uint 64t, and this is pointer. So this is the value, uh, and I need this is a key for
Hmm.
me, and get value. So what I do is hash, okay, value, okay, key, sorry, key, get value, okay, let's say hash get value, and then I use address,
Hmm.
right? And then whatever key is there, let's say if my key is negative, let's say, right, let's say hash returns negative if there is no key,
All right.
then I'll just do some panic because now I don't know what to do, right?
Hmm.
Let's say return error or something -1, let's say.
Hmm.
If not, then I'll just do key free, and that should, sorry, value.
Hmm.
Why this is key? This should be value.
Well,
Yeah, I
maybe
think this should work.
line 50 as well. Line
50,
51. Sorry.
51. Okay, yeah,
Well,
of course, value.
yeah.
And then whatever is
Hmm.
returned from free, I will return that as well.
Yeah.
Maybe that is required for user. So yeah,
Hmm. Right.
this is the way I am thinking I will implement. This
Hmm.
time in hash, I was given 352. I
Hmm.
calculated 351 and then freed that because
Right.
that's what
Right.
my malloc returned here. Okay.
All right. I think the code looks readable to me, and I
Mhm.
can make out easily what you are trying to achieve here. So
Mhm.
that's awesome.
Okay.
One food for thought for both of us is, can we get rid of hash? And one maybe nudge to the direction is in line 32, right, where we
Mhm.
asked for extra size. Can we ask for some more extra size and store the pointer which we got from the
Hmm.
malloc there, and
Right.
then retrieve it in the free, and then.
Nice.
And if you are watching till the end, thank you so much. We'll see you in the next one.
Yeah,
Awesome.
and
Have a good day.
please like and subscribe. If you do so, then we get a hint that okay, we want to continue this series.
Yeah. Yeah. Is this the indication to us that we are,
Right.
sort of going in the right direction and we should continue, or we should venture into something else?
Yeah.
That's
Yeah.
the only indication. Okay. Awesome. Have a good day, folks. See you in the next one.
Yeah.
Bye
Thank
bye.
you. Bye.
Yeah.